It is possible to factor trinomials like these for which no common factor exists, and the leading coefficient is 1. Recall that when factoring, we are writing an equivalent expression that is a product. For these trinomials, the factors will be binomials. To understand how to factor a trinomial, let's review multiplication of binomials using the FOIL method. First terms of each binomial multiplied, in this case, result in x squared. Outer terms multiplied together, 1x. Inner terms of the two binomials multiplied give us 7x, and the product of the last term of each binomial is 7. We then combine the like terms for the product. The coefficient of the x term or linear term in the trinomial is the result of the sum of the constant terms in the binomial. The constant term in the trinomial is the product of the constant terms in the binomial. These observations lead to a method for factoring certain trinomials. Note, each of the constant terms in this example have positive constants, and the trinomial has a positive sign on the linear term, or the x term, and a positive constant term. Let's take a look at the product of these two binomials, one with a positive and one with a negative. First, we'll multiply the first terms together. Next, outer terms, inner terms, and last terms. Simplifying gives us x squared minus 2x minus 15. The coefficient of the x term in the product of these two binomials is the sum of the constant terms. 3 plus negative 5 results in negative 2. The constant term in the trinomial is the product of the constant terms in the binomial. Note here, with one positive and one negative constant term, as in this example, the resulting trinomial from the multiplication of the two binomials has a negative constant. It's important to note the signs of the constant terms and the middle term of the trinomial for factoring purposes. To factor this trinomial, think of FOIL method in reverse. Since the leading term is x squared, the first term of each factor is x. To complete the factorization, we need a constant term for each binomial. The constants must have a product of 10 and a sum of 7. We list some pairs of numbers that multiply to 10, and then check the sum of each pair of factors. Here we start with 10 times 1, which is a product of 10, but when added, those factors add up to 11. This is not the pair that we're looking for. The next factor possibility would be 5 times 2. When added, give us 7, the desired middle term that we're looking for. So replacing the last terms with 5 and 2, to check whether this is correct, we'll multiply using the FOIL method, simplify, and we do have the trinomial that we're factoring. In this problem, since the first term is x squared, each of the first factors will be x. Next, we'll look at the factorization of the constant term. These two second terms in each of the binomial need to multiply to give us 6, but also add up to give us 5. Looking at possibilities, 6 times 1 multiply to be 6, but when added give us 7. Another factor pair, 3 times 2 gives us 6, and when added gives the sum of 5. Replacing the last terms with these two factors, and to determine whether this is correct or not, we'll use FOIL method for multiplication, simplifying, and as long as we get the same trinomial, we know that these two binomials are the correct factorization. Factoring this trinomial, again with a 1 as our coefficient, y squared will break into a y and as the first term of each of the binomials. Since the constant term is positive and the coefficient of the middle term is negative, we look for a factorization of 12 in which both factors are negative. So to start, a negative 1 times negative 12 would be a possibility. They do multiply to be the positive 12. When adding, we find it's not a negative 8. Another factor pair, both negative, result in a product of positive 12. When add, they have a sum of negative 8. Here we have the factor pairs that we need for the last two terms in each of the binomials. Again, to check a factorization, we multiply and see that we've factored it correctly. Here in this trinomial, we have a leading coefficient of 1 on our x squared, which will break into an x and x. This trinomial, though, has a constant term of a negative 20, meaning one of our factors will be positive and one will be negative. We want the two second terms to multiply to give us a negative 20 and add to be a negative 8. Here's the list of all the possible factors, and if you notice, we start with a positive times a negative, 1 times negative 20, all the factor pairs, but then reversing those where negative 5 now becomes positive 5 with a negative 4, and continue on with switching the signs of each one of these three possible factor pairs. Then going through, adding these factors together, looking for the pair that results in a sum of negative 8, you can see the pair that works. Replacing the second values, we have the following two binomials, and to check this, as in the past, we multiply and verify that we do have the correct answer. Before attempting to factor this trinomial, write the trinomial in descending order. So we switched and put the 5t in front of the negative 24t so that it follows the pattern that we've become accustomed to for factoring this type of trinomial. Our t squared was the result of the first two terms each being t. In this problem, we're looking for numbers that multiply to give us negative 24, which would mean one is positive and one is negative, and add up to be the 5, which is the value on our middle term. Here's our possibilities, and notice we didn't switch the sign here. These are just the four factors combinations for the product of two things equaling negative 24. Adding them together, we're looking for 5. Now, if we had ended up with a negative 5, perhaps we'd had a 3 and a negative 8, and we're only off by a sign, we would know then that we needed to switch which one of these two factors was negative. Here's our pair, resulting in the middle term we desire, and again, to check this, we will multiply, simplify, and verify that it is the original trinomial, with these two binomials being our factorization. Polynomials in two or more variables are factored in a similar manner. Whether the middle term is AB or BA, it is the result of the outer and the inner terms being multiplied using the FOIL method for the product of two binomials. So as with the last problems, a squared was the result of the first terms being multiplied together, which is a in each first term place. We're looking for factors of negative 21 for our second two terms, and recognizing we also will have to have a b in each one of those terms as well as that constant term. So for our product of negative 21b squared, and for the sum of these factors, we'll only be looking for the 4b portion because our a is already taken care of in the first term. factor pair possibilities, with it being negative, one has to be positive and one negative. Here we have an option. Checking the sum, we have a negative 4. We're close. The only thing now, it's 7 and 3 are the factors, but this tells us we need to just switch the signs from which was positive and which was negative, and the result will be the positive 4b that we were looking for. We now have the second term for each binomial. Again, going through the process of checking, and we see that we have factored it correctly. Factoring this one, we look at our first term. The result of this first term is having an x for the first term of each binomial. Since 5 has very few factors, we can easily check all possibilities. Factors of 5, both signs being the same and both being negative, will give us the following possibilities, looking for that sum of -1 of -1 times -5, when added gives -6. Since this is a prime number, we have no other options, and when this occurs, we find that this polynomial cannot be factored using the rational numbers. It is said to be prime. Often factoring requires 2 or more steps. Factoring means to factor completely. When factoring, always look for a common factor. Inspecting the 3 terms, we see that we have a 2x as our largest common factor. But since the leading coefficient is negative, we're going to factor out a negative 2x so that our leading coefficient has a positive, and in this case a positive 1 coefficient. So factoring the trinomial and simplifying gives the following for a replacement of the original trinomial that was given. But looking at the remaining trinomial, we should always consider the possibility that it can be factored further. This looks similar to what we've been factoring. If we look at our first term, the first term is the result of the first 2 terms in each binomial, which will be x in this case for each. Next, we're looking for factors of our binomial second terms that multiply to give us 25 and add up to give us the -10, which is the coefficient of our middle term. Because the constant term is positive and the middle term is negative, it tells us that both factors are negative. Here we have a first possibility, adds up not equal to the sum that we're looking for. Another possibility is that both the factors are -5, which do in fact add up to be -10. So replacing our second terms in each binomial, we have the following. When we have had more than one factorization, we want to make sure that we include all the factors that have been factored out so that we have a product that is equal to the original expression. So checking here, not only do we have the binomials which multiply to equal the trinomial, but we also have this largest common factor here, and multiplying the 2 binomials together and then multiplying that result using distributive property with this coefficient, we do verify that we've factored this correctly.